I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the catch-all filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the see all sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information by downloading Bulletin 40-10 from Sporlan.com with all the catch-all filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. What's going on this week, man? I missed you last week. I was working nights and ended up dying or feeling like I was dying, so I didn't get to record with you last week.
Yeah, nights are no fun. I try to avoid that at all costs. Well, this week I'm just kind of tying up some projects back at home and kind of trying to clean up some stores, even though they're not ours. Some messes we inherited, and I stumbled upon a glycol rack that I have yet to fix. It is pretty much, stumped me for 2 days. So maybe I'm going back tomorrow to try to fix that and figure out what's going on with it, but it just won't pull the glycol down. Everything's working properly, it just won't make temp.
You got to remember, though, how many times do you get a freaking phone call while you're trying to fix the shit that you're working on? You know what I mean? I've been in that same boat. I know. I've been in that same boat where you're trying to fix something where you legitimately are having a difficult time with, and your phone just won't stop at all.
Yeah, it was that, and then every 2 minutes, can you dial up this store? Can you dial up this store?
No, I got a bomb in front of me. Leave me the hell alone.
Yeah, can you look at this store too? Do we need to go to this store?
Is it a real service call? I don't know. Just go. I'm in Georgia this week. My boss actually said last week to me, he said, yeah, you worked all night and you were working all crazy hours and you're going to stay home next week. I'm like, okay. Monday, around 11 o'clock, he's like, check your email. I was like, no. He's like, I think you have to go to Georgia. I'm like, you said, I know. So I got to, it's a prototype. It's basically an HVAC air handler with all kinds of crazy controls and defrost and such that does like a stacker, like basically like an automatic stacking system that they have, kind of like in airports and stuff. Really, really cool stuff, and it was extremely challenging and fun. Like I was actually having fun working on it. And then a buddy of mine actually just drove up from Tennessee. We went to a Korean barbecue, and now I have meat sweats.
That sounds disgusting. Korean barbecue.
Oh no, absolutely not. Absolutely not.
I mean, how could you even eat that after where you live in that sweet, delicious barbecue that's all around you?
I had so many meats that I didn't know that you could actually eat. Beef belly. I had just so much food. My wife's buddy is Vietnamese, and she just kept ordering. This girl is probably smaller than my 13-year-old and probably packed about eight plates of food away. I have no idea. I have no idea. No idea. She's like, just keep ordering. I'm like, I can't. I'm gonna explode.
All right, today, guys, we're gonna go over something that sounds pretty basic, but it ends up with a lot of callbacks and a lot of newer guys struggle with. And
rage quitting.
Most people don't struggle with that. It's
sorry.
pretty easy.
I tried.
We're gonna go over how to find a short in a rack or like a condenser unit, and some like basic electrical troubleshooting skills, and how we approach these things. So we're gonna start it off. So I mean, finding a short in a rack could be one of the worst things you have to possibly do besides trying to find a refrigerant leak. It's real hard. I mean, shorts could be just as hard to find as leaks. Yeah, I mean, it depends. Depends where it is and you know how old the rack is.
Yeah.
So
well, I mean, go ahead. Sorry.
Go ahead. No, go ahead.
No, I was gonna say it depends on what it's taken out, right? I'm sure everyone on here has probably had one head cooling fan on a low temp rack take out a main fuse, on the MDP, on the main disconnect panel. And you're like, well, it worked. It worked. I don't know what happened. Like just intermittent stuff. It could be moisture based. I had a rack that was, every time I would go into defrost, the header was just, had small pin leaks, in the insulation, and would just, kind of leak down onto the head cooling fans and gone.
I've had head cooling fans blow the main fuse of the store.
That's fun.
Yeah. I mean, I don't know why these jackass manufacturers put 460 volt head cooling fans on and not 208, 230 or 120 volt ones. They put 460 volt head cooling fans on and wire them right to the compressors with a 60 amp breaker because that's safe.
Oh, it is, right?
I mean, you've been in a room when one of those explodes, right?
Actually, I had a kid. I was teaching him, what to look for with shorts and stuff. And whenever you turn something back on, you just stay the hell away. Or like, one of the biggest things, when you're working on anything where you're turning it on for the first time after you had a short, you always stand in the crook, hinge side. So if God forbid it does have to come open, it basically, you're shielded from the door at least, And the kid was checking all the head cooling fans because we had an intermittent short. And he's moving shit around. I was like, all right, step away. And I turn it on. It runs. And he goes in to go just a little bit close. And it arced in front of his face and scared the living shit out of him.
Yeah, I have a 2x4 in my van for that.
Yeah.
Just, poking and prodding when that kind of stuff happens.
Yeah. Well, I mean, like we said before, I mean, like it depends on how old the thing is. You can have a short in the raceway. You can have a short in the bus duct. You could have, a short in the flex. A lot of times when guys are putting new compressors back in, they're not really watching where the hell they're putting stuff, and stuff is rubbing against vibration eliminators or whatever, causing excessive heat, and then causing a short. How do you, let me ask you a question. Like, how do you start? Like, let's just say you have, let's start with control fuses, right? If you have a short, something that's busting instantaneously, nothing that, that gives any time, where do you start?
So I look and see what it is. And, my wife's apparently closing the garage door right now. They're loud. So I look and see what it is. Like if it's a circuit, I'll narrow it down to a circuit. If it's a compressor, I'll narrow it down to the compressor. It depends what it is. If it's an RO, if it's off of an RO board and stuff like that, I'll isolate just that one component, and then I'll break out the meter and start ohming it out to ground. See if it's got a short to ground. I'll ohm it to common and see what the ohms are there, and then if that all ohms out good and I don't have any direct shorts or anything, then I'm going to start looking to where that goes, what component it goes to, and see where it runs. And then I'm going to start following the wires around and see where it goes to and where the possible short is.
Gotcha.
Fuses don't explode, either do circuit breakers.
They don't?
Well, I mean, yeah. When you open up a rack panel, there's a fucking pile of fuses there. It's usually not a good sign.
So actually, one of the things that I have in my van, or no, I did when I had a van. Now I drive a soccer mom vehicle. So before I have a bag of breakers that I bought from Granger. Anything running from a 5 amp, 2.5 amp, 10 amp, and they're all double pole in case I need it. But basically, in case you have something, because I mean, obviously, we've all seen that guy that goes through a box of fuses, right? And sometimes like it is, it's the short is that difficult to find, where it's just a bastard to find. Rooftop units are extremely bad too. Where you don't know if it's, especially like fall, summer, springtime. You don't know like what it's running at that point in time. So you could have the heating running, the reheat running. So basically, you have to just kind of step it through and step each thermostat step through and just kind of start shaking shit around and see if you can find that intermittent short. You guys should be at this point in your career familiar with Ohm's law and how that works. Checking, knowing when a contactor is basically out of its range of, what you could ohm it. Cause you could have one contactor, you could have a Eaton one on the left and you could have a Copeland one on your right. And, they're close, but they're just a little bit different as far as ohms. So I've seen guys question themselves. Well, I don't know if that's actually bad or not. So if anyone doesn't know Ohm's law, it's basically voltage divided by resistance equals current. So if you know your voltage and you know your resistance, you can figure out what your current is. So example, like if you have a 240 volt circuit and, let's just say your ohms on your coil is 500, that's going to give you a half amp, a 0.48. So you know that if they have a 2 amp fuse in there, that'll be sufficient. Now, if you have 240 volts and you have, let's just say 120 ohms, that's going to be 2 amps. So you're gonna blow that thing instantly. So you can use Ohm's law to basically kind of see if whether it be a solenoid coil, you can use this for any kind of resistive load. Solenoid coils, contactor coils, small relays. Anything you want to add to that, Chief?
No, that sounds pretty good. Just using Ohm's law to try to figure out everything. And I mean, just like you said, use things that are around you and just look around for that stuff. I mean, that's the biggest thing. I mean, for like transformers and stuff, but just some transformers, when you do them, I mean, when you check like a transformer, like the secondary or primary, just be aware of like multiple different transformers are going to ohm out differently. So, I mean, they're not all going to be the exact same. You could have
they should be close.
It'll be close, but not. Yeah.
If you have a 480 to 120, right? That's a 4-to-1 ratio. So basically, let's just say you have 4 ohms on your 480 side, and technically you should have 1 ohm on your 120 side, right? To make that ratio fit, right? But if you go from the primary side to the secondary side, remember this is done by inductance, right? So the wires actually aren't touching. It's the magnetic field that's basically making that voltage step down. So we shouldn't have any continuity between the high side, the primary side, and the secondary side. If you do, those two wires are shorted together.
Then you let the smoke out.
Oh, you can put that back in. Don't they have bottled smoke or something?
Yeah, not enough of that. And those big transformers explode big time.
Yes, and since you're talking about things exploding, carbon, guys, carbon is extremely conductive. I had a guy down in Uvalde, Texas, that's just damn near Mexico, and he got a service call where I think the store's single phased, and basically burnt up. Yeah, it's single phased. heated up a breaker. The breaker basically melted, and then single phase from 460 to 460, and splattered carbon and steel all over the place. Because remember, short, when you have a phase-to-phase short, it's hotter than the sun, and it will shed molten metal into everything. And the guy got a brand new fuse block for the one that was totally damaged and reused the one that just got a little bit of flash on it. So he hooks it back up. I'm in another part of town. He comes to pick me up because I was in there. I was training in that area. And he said, Brett, I don't know what I did. I checked for shorts. I checked for everything else. I hooked it back up, and it burned up the same damn way. And I'm checking for shorts, and I'm not finding anything. And at this point, he had the fuse block that then melted the second time, basically disconnected. So I'm looking for a short for about a good 2 hours, and I'm not coming up with anything. I'm using my Megger. I found a loose connection on a damn primary big-ass transformer. And what it ended up being was he was hiding the evidence. From the first short, it shedded metal and stuff inside, in the plastic of this fuse block. So we took the fuse block and actually just mounted it to it with no wires, went from plastic to metal, and used my Megger, and it shorted directly to ground. So basically, when he hooked it up the second time, the 460 was going right through the metal, right through the plastic, right to ground, and burned up the same set of wires. So I mean that goes the same thing when you have a blown out contactor. You see that big black crap all on the inside of the control area. Clean all that crap up. Use degreaser, wire brush, inside the pecker head on the compressors. I've seen those short. I just had one recently. I was down in Houston working with a kid, and he had a contactor that blew out, and then it caused a short on the other end. And we actually had continuity between the actual ground of the compressor and the actual plastic block, which was causing a direct short there.
So now that you brought that up, so when you guys have a short in a compressor, if you get a compressor trip in a breaker, yada, 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 you get it short, do not just condemn it by ohming out the wires at the contactor. You need to pull the wires off the compressor. I have seen this bite guys so many times. I remember my last shop, I was putting in like an $8,000 6D compressor, and sure as shit, went to go turn it on, and the fucking thing exploded. Blew the breaker again. Well, what the guy didn't do is he didn't pull the wires off, and there was a short in the whip. So, I mean, they bought an $8,000 compressor for $40 worth of parts.
So I posted that one video of me doing that, and I didn't show myself checking it. I just checked it right at the unit itself. And I got my ass lit up for it. Everyone's like, "You didn't pull it from the contactor. You're checking right at the wires. It could be in there." I was like, "I know," and I checked it. Yeah, sure you did. No, I did. I just was on a service call, and I was trying to get home at 12 o'clock at night. But yeah, he's right. Always pull it from the pecker head, and actually, check from phase to phase. And a lot of guys that, they usually don't replace the pecker head with the new one that it comes with. They usually use the old one. Please replace the module, the overload protection module. Don't use the old one, and make sure that you actually screw the screws down tight. I've seen, someone didn't.
Time for that?
What's that?
Who has time for that?
No. So I seen one. Where someone put in a compressor, and basically the screw unscrewed itself from the vibration and went right from ground to phase. And like, because it's so close on a bitzer, it just shorted the hell to ground. And I was ecstatic. I was like, I found it. Great. And yeah.
One time I put a $25,000 bitzer HSK screw in, and we hooked it all up, and you got to put the ground lug on there, and it's like an 8-gauge ground lug.
Mm-hmm.
Well, I didn't torque it down with the torque wrench because we were getting pushed to get it done, and 3 days later, the ground wire came loose, went off, hit L1, blew up a $5,000 drive, and took out the compressor. So we were like $30,000 into it after that. Yeah, big mistakes.
Yeah, people don't think that there's this misconception that I don't screw up. Oh, I do. I just
when you screw up, big screw ups.
You got to make it worthwhile. I had a Hitachi screw the one time, and it was a Y delta start. Now, so if anyone isn't familiar with Y delta start, there's different ways to actually start a compressor. We have full across the line start, which is typically what we usually have, right? Which is just all three phases pulling at the same time. You have part winding start, which you'll split the windings up, where you basically pull in one contactor, and usually a couple milliseconds after, or have it on auxiliary where it'll pull in directly after. And it's basically to, not have to use as thick of a wire, because it's less inrush. Y delta start basically uses three contactors. You have M1, S1, and M2. Basically M1 and S1 pull in at the same time, goes to a certain RPM or a certain time, then it kicks out S1, kicks in M2. And basically, it sounds like it kicks in a high gear. Well, this Hitachi screw, like it would start running, and then it would get up to a certain RPM, and then the fuse would blow. At first, I thought I put it in backwards, but we had checked it with the rotation indicator to make sure it was going the right way. So I knew I didn't damage the bearings or anything. And this was a weird one, because basically every time I would do it, it would ramp up to a certain RPM, and then it would just pop to 460. And basically, it took me hooking up my Megger, disconnecting the suction service valve, because usually on a screw it's directly in the ass end, right in the center, and basically hooked onto the rotor bolt in the back, and just turned it an inch at a time and megged it, inch at a time, megged it, inch at a time, megged it, and finally there was a low spot on it that apparently when this compressor got rebuilt, they rebuilt it with ship bearings. So it took me turning it probably about 15 different inches before I actually figured out that, okay, there's a short right there. And when we got the report back, it showed that exactly. There was one low spot in the bearing, and they said that I ran it backwards, but I didn't. It was, because whenever I do any kind of screw, it does have protection, but, I just like to be safe with, having the rotation indicator to make sure it is running the right direction. Rotary screws, centrifugal pumps, very, very, very important that you run them the right rotation.
Yeah, funny you brought that up. So I was helping out in service a couple weeks ago, and they had a rack down in a Walmart, and I get there, the original contractor's already there, so we're the sub now, and can't figure it out. So I get there, I start going through stuff. Everything's off on high head. Condenser breaker's blown. So I look at it, I check it. There's no shorts. Reset the condenser breaker. I'm looking around. All of a sudden, the drive goes into ground fault. Okay, well, usually the drive's right. So I'm like, go up there. I start ohming out every motor. I find two that were already shorted and had the fuses pulled. I'm like, okay. I go to start it up. Ground fault. Okay. And it goes for like a second, and then it goes to ground fault. So I grab my Megger out. I start megging every motor. None of them meg out bad. I'm like, okay, what's going on here? So I go to restart it again. Ground fault. I'm like, what the hell is going on? So I look, and then one of the motors is moving. A couple of the motors are moving a little bit with the wind. I start looking. All of a sudden, one of them megs out bad for a second. The whole condenser megs out bad for a second. Then it stops. Then as it moves again, it megs out bad for a second. So I'm like, what the hell? So I start pulling fuses, and finally I find this motor. Whenever it turns and it gets to a certain spot, it megs out bad and ends up causing a ground fault. So it would get halfway around, and it would knock the condenser out.
We talked about this, like just with compressors, it's essentially a mechanical electrical failure, right? It's a mechanical failure in the bearing that eventually ends up causing an actual electrical failure, right?
Brand new Juggernaut motor.
Really?
Yep.
Garbage.
Yep. It wasn't even 2 months old.
Was it rated for the drive?
Yeah. They say they're drive rated.
Inverter duty, right?
Yeah, inverter duty. And it's guaranteed to fall off into the condenser.
Duty's right. So about condensers. Everyone's familiar with the bone Heatcraft terminal strip where basically the 3-phase comes in, and then there's like 400 freaking Stacons on there that go to all the condenser fan motors, or at least go to the fuses that then go to the contactors. I was up in Connecticut, and whenever it would rain, only when it would rain, it would basically end up tripping out. And basically, I was doing the same thing you did, and I started pulling every single fuse, and it did it just from the disconnect to the fuse. And I'm looking up as I'm hitting the megger, and so if anyone's ever used a megger, basically it's inducing voltage. DC voltage is basically to find a short. You're supposed to basically double whatever voltage. So if you're dealing with 460, you're supposed to induce it with 1,000. If you're dealing with 250, you're supposed to induce it up to 500. So anyway, so I'm dealing with 460. I'm inducing 1,000 volts, and I hear it sounds like a taser. And I'm trying to listen to where it's coming from, and basically that red, I guess it's like fiberglass, right? Would you say it's fiberglass, man? Where all the terminal strips are?
Yeah, it's some kind of like fiber material.
So anyway, so in between there, it was arcing. It looked like a fucking little Tesla bolt that would go from there back to there. So we basically, for the time being, we took the piece of the thing off, wrapped it with electrical tape, put it back up on, so until we can get a new one and get it all ordered. But that's essentially what it was. Somehow, some way, I don't know if it heated up from a loose connection on a condenser fan motor and just made it weak. But like I said, that extra moisture from the air, whenever we get, start raining a little bit, it would end up shorting out. So, moisture can be a bitch too, just trying to find something. Sometimes shorts, you don't really ever notice them. A lot of the older racks you're using BX, basically metal flex. Is there some different name that you call it, just in case, because I have weird names for some shit? Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry. Repairing refrigeration lighting can be performed quickly and profitably by utilizing the Luminosity Kensington Refrigeration LED. Kensington was developed by the supermarket refrigeration community to be a near universal solution for refrigeration lighting repairs. At Luminosity, we saw the frustration of technicians making multiple trips to the store sites to determine the correct parts. Labor pileups, dispatch remains open for months, high prices for the replacement parts by the OEM, and customers refusing to pay for all this effort, leading to unbillable or end-of-life invoices. Our goal was to develop the Swiss Army knife LED that technicians can carry on their trucks or at their shops to provide a one-and-done lighting repairs at a profit. Once your customers experience the clean, bright Kensington LED, they will be asking for more and making you more profits. The Kensington LED features secure metal mounting bracket for an internal driver, near universal solution for reach-in doors and air cases, walk-in and prep rooms, one-and-done repairs, easy and labor efficient to install. They have a built-in LED driver that has a universal 120 to 277 volt input, easy and secure mounting, HVAC and refrigeration contractors in the United States. They're made for damp locations, rated IP44. They have a 7-year warranty, available in 4, 5, and 6 foot lengths, and they're tested in all major brands of refrigeration units. They're also utilized by most of the major. For information and pricing, please contact Pete Murata at Luminosity. His email is Pete, P-E-T-E, at I-LUMINOSITY.com. His cell phone number is 209-814-8129. Check out Kensington Refrigeration LED and our full line of quality products at www.iluminosity.com. That's www.i-luminosity.com. Thanks for listening, guys.
No, it's BX.
So, be mindful, when you're using BX, you can use Kevin's old 2x4 trick. Start, beating around if you think, or just inspect it and make sure a lot of times you'll see pit marks in it. You'll see black marks, actually going through.
A lot of times, like I'll if I have a main short, the first thing I'm doing after I make sure nothing is grounded at that current time, I go right to the compressor whips and I check them where they 90 over out of the bottom of the cabinet. That's a place where they short out a lot, where they go out of the bottom of the cabinet. And then I start looking through all the whips. I take my hands and I run them down the whips. Shut the compressor off when you're doing this, unless you want to get a jolt.
Jolts are fun.
And look for holes. I mean, hopefully when it goes to short, it blows a hole. If not, if you reset that breaker a few times, it will blow a hole. I mean, I've had shorts where they're like a pain to find, and where they don't blow a hole, and that's where the 2x4 comes in. So you think I'm joking? I'm not. I'll start, tapping on stuff with a 2x4. I'll start tapping on all the whips, just tapping up and down, moving them around, trying to make that short. You got to remember, like, that compressor's vibrating. That thing may not short for like another week or two. I mean, we had a store where the control breaker was blowing every other day, and finally I went there. I turned the lights off in the compressor room, and I went to town with the 2x4, just smacking on stuff. I ended up finding like 5 rub throughs. I mean, this was an old Kaiser Warren rack. I mean, there had been 40 BX whips coming out of the electrical panel, going every which way to solenoids and everything else. And finally, I ended up finding it. I mean, it was in a BX whip for the subcooler. So that being said, when you're at a Walmart and you're working on Novar, especially old Novar, nothing is fused. So none of your compressor outputs are fused. None of your rack output modules are fused. So if you have a short and it's bad enough, it's going to blow the point. So if you go to a Walmart, you have a bad compressor point, a bad circuit point, don't just go to move it or order a board. Make sure you don't have a short first. Same thing with the cruisette time delays. So a short will take out a cruisette time delay before it'll blow a breaker sometimes. Yeah. And then same thing with the Novar board. So nothing is fused on a Novar board. So that's why at a Walmart, when you end up getting a short, it ends up blowing a control breaker. Whereas in, like, if you had a CPC or microthermal store or a Danfoss store and you have a short on a circuit or a short on a compressor, I mean, generally it's going to blow that RO fuse depending on where it's at in the line for the electrical. It may blow the RO fuse and that'd be it, or it may take the whole rack down. But Novar, it's going to blow a rack breaker every time almost, or it's going to blow a point. So that's what those junky Novar boards are junk.
Well, no, that's good marketing on Novar's part, right?
Well, yeah,
you sell wholesale boards.
They sell boards that you can't get anymore.
Yeah, you actually. So, well, yes and no. So the new boards that they sell, they will work. There's a certain, like, if it's a old ROM, it's like an ROM, or it's an IXO, AOM, or I'm sorry, COM, and then at the end it'll have an S, and S stands for Spectrum. So it'll actually go on the Spectrum network, and those actually do have fuses, if I'm not mistaken. Yes, they do. So, yeah.
Yeah, all the new boards have fuses. They don't really work though, so I mean, good luck with that.
Yeah.
I will just say like I can't say nice things about them, so I'm not going to say anything.
Please don't. No, I had a thought and it just eluded me because you were talking about shorts. Damn, there was something.
So well, I'll go over the other things. So like once I find it, I mean, I'll generally, if I could see it, through the BX whip, I'll pull out one wire. If I can't, then you pray to God it's not in a compressor. You don't have to cut all the wires, and rewire everything. You know, you're going to pull that whip out, but change the whip too when you do it. Don't just shove it back in there with some tape, and don't change the whip because the whip is going to have it's going to be jagged on the inside now. So make sure you change out the BX whip. That's the nice thing about Zero Zone. What they did is they end up using a lot of times Seal Tight.
Yeah.
That corrugated black Seal Tight with the non-metallic. That stuff's awesome. It pretty much eliminates that.
Absolutely. You know, it's not as temperature resistant though. I think that you just can't have it sitting on a discharge line. Yeah, that's like I said, that's why I have like, just in case I have something difficult where it's, I've checked everything, everything known, everything possible, right? If you checked everything possible, it has to be the impossible, something you never think about, something off the wall, and so that's why I have those, basically those breakers there, so I can use that instead of, 40 different damn fuses,
Yeah, and that's the other thing is don't trust the last guy for fuses. Make sure you got the proper fuses in there. You don't want to be trusting the last guy when you get like an induction motor and you have current fuses in there when you should have time delay fuses. You want to make sure.
Explain the difference, because I guarantee that's something that guys don't understand.
So when you have like an induction motor, an induction motor obviously has locked rotor amps and pulls a little bit more on startup. So you want a time delay fuse in a motor or a compressor or something like that. You want something that's going to have a little bit of a time delay before it blows. So that way you could get past that peak amp draw and still have protection. So for other things like heaters, you don't want the time delay fuse. You want a fast acting fuse. You don't have that inrush with a heater or an inductive load.
Correct.
So that's one thing. I found a condenser the other day. The in-house guys put a bunch of condenser fan motors. They put a bunch of wrong fuses in.
Yeah.
And
they don't take the inrush really well, right?
Nope. And they were it was an older condenser, and the motors were twinned together, so they were starting off and they were off the same set of fuses, and they only had about 3.5 amps to spare. So as soon as it would go to turn both of them on, it'd blow the breaker. Oh, well, we got that. So condensers. When you're having issues with condensers, especially Heatcraft, they just ran wire into rails. So they just took like number 14s and they just run the rails of the condenser. So that is a huge short spot, like in the condensers. So you want to just be aware of that and just make sure, if you're going to condemn a motor, check the wires out. If you see it's all starting to crack the UV protection on the wire, I just pull SJO cord to it. I just run a nice SJO cord to it, so where it's protected and you don't have any problems. And if the condenser is more than 10 years old and I'm changing a motor, I'm going to pull new wires.
Explain what SJ cord is.
So it's just a rubber coated cord, almost like an extension cord, but not an extension cord. Using an extension cord makes you a hack.
Extension cord bad, SJ cord good.
Yes.
Oh, I remember now. So remember, when you could be looking for and I know I'm kind of flaking all over the place. It's been a long week. When you have safeties are always in series, right? And safeties are either going to be open or they're going to have like 0.1, 0.2 ohms going across. Loads are always going to be typically in series because we want, parallel. Sorry, loads are in parallel. Safety's in series because we want high pressure, low pressure oil, basically to open up and kill the loads. But like I said, the loads are going to be in parallel. Make sure if you have a fuse that's intermittently blowing that you check the ohms with no voltage applied across each one of those safeties. Because I've had, a set of contacts that basically, let's just say you have a contact that burned out, coil burned out, and, ended up causing a little bit of weakness on the contacts for, low pressure switch, high pressure switch, whatever. And basically now, instead of having like 0.1 or 0.2 ohms, you have like 5 ohms going across that. Well, if you do Ohm's law, you're now dropping voltage across that low pressure switch, which means your contactor is not going to get the correct voltage as well, which means your amperage is going to increase, and then you're going to end up, popping your fuse. One of the biggest things that that you should be checking, especially like Hussmann's real big with using Hussmann and Zero Zone. I think are real big with using like the encapsulated pressure switches that have the it's like a 3-wire plug, has a ground. Sometimes it has an alarm set of contacts. You pull that thing apart. You loosen the nut on the back end side that actually lets the wires slide in and out. Take the whole assembly off the low pressure switch. Pull the long bolt or the long screw out, and you can actually separate that. And behind there are very, very small flathead screws where basically it bolts down those wires. Vibration, especially on startup, will loosen those up and cause you to pull excessive voltage across your safety, and then basically end up blowing out your fuses. Have you ever seen that, Kev?
Yeah, I mean, I've seen it before on those. I'm not a very big fan of those things, just for the fact of the way the connector is, and it seems to loosen up over time. So, yeah, I try to avoid those things.
Well, it's European style, right? And like Americans, we're hard on everything. We're just, everything's, we're gonna make it industrial. We're gonna non-break, and Europeans kind of elegant, so they make it all pretty and isn't really sometimes the most durable. Just saying.
I would have said worse, but
yeah,
especially since I just put in like 60 of those things.
What the high pressure switches
and low pressure switches.
Why did it go bad?
No, I had to do them when I did that Costco conversion. Yeah, the low pressure switches are a pain to adjust. So just so you know, you can adjust those black encapsulated pressure controls. There's a little like.
No, don't tell them.
It's a little tab on the bottom where you could pull it off and adjust it. So we kind of went over like how to find the shorts and all that stuff. Look for carbon tracking, checking all the wires, pulling on them. I mean, if a breaker blows or something like that happens, I mean, you're going to want to try to find a short. Don't just throw a fuse in it and walk away. Somebody's going to end up back there. It's going to be a callback. Making sure you got the right fuse or whatnot. I mean, it didn't just happen. So,
no. Well, listen. I have a phone number that they can call for technical support if they need. Should I give it out?
I'll kill you. So the next thing I want to go over is kind of some basic electrical troubleshooting with I mean, obviously this would be a lot easier on a video, which we'll do in the future. But so electrical troubleshooting, when I'm troubleshooting anything in a rack or a panel or anything. So, I mean, I see a lot of new guys doing this is the ground. You never want to really go to ground. You always want to go to common or L2 when you're checking control stuff. So what I do, if it's a compressor, I will figure out what wire's L2. I got the clamp on alligator clips for my Fluke. I land it right on the L2 on the contactor. Then I check L1 at the switch, make sure I have, 208 or 120 volts. And if I do, then I start going down the line. And all I do is take the meter in my hand and I hopscotch from safety to safety to safety to figure out where I don't have 208 or 110 volts. So that way I'm not looking to ground to see this and that. I mean, that could be deceiving sometimes. I mean, Hussman racks are by far the best for people to learn how to electrical troubleshoot on. I mean, that's how I got as good as I did. I mean, Hussman prints are nice, and the terminal blocks around there are nice because you could literally troubleshoot every safety from inside the rack panel. You don't have to take anything apart. Usually you could just go from terminal block to terminal block to terminal block to terminal block, and then you can, figure out where you're open at. Now, just like when you have voltage across the safety, it's open. When you have no voltage across the safety, it's closed. It's a switch. So that's what you want to look for when you're going through that stuff. I mean, you could still do that hopscotch method on other stuff. And, I mean, you may have to move around, pull some safeties off, but I always leave one side of the meter lead clipped to the common on the contactor, and I'll go around through the safeties or go into compressor pecker head. Just when you're doing it, shut the voltage off the compressor pecker head, the main power, just in case it does pull in. I mean, that way you don't get, lit up. And then I go through each one.
Well, one tip for that, because people don't have 8-foot meter leads. What you can do, because usually, your oil fill control is always going to have, your L2 of your 208, right? So you can basically strap on right there, because that's going to usually go to your single pole double throw switch. You can strap on right there and use that for the hopscotch. But like you said, with Hussman racks, it's awesome because all the safeties basically run back up, except when you're trying to do a conversion for a Costco, for a microthermal board going from a 504 to a compressor board, and that damn terminal strip doesn't want to do anything because you're too sweaty and hot and can't get the damn thing to shut. Take the damn wire.
Yeah, I will admit that they could have moved those terminal strips up like another inch, and I would not have hated my life so much a month ago as I was rerunning 35 wires a day.
Dude, I lost, so I work with this kid, amazing kid. He's really coming up. His name's Greg King, and I lost it in front of that kid. I started hitting shit. We had been working all night, and we were working nights, so it wasn't so damn hot. And basically I just started punching shit because I couldn't. I must have tried to shove the same wire in the same freaking terminal strip about 60 freaking times, and every single time I tighten it up, go to pull, and it just pull right out. I'm like, I'm done. I'm walking the fucking way. I'll be back. We had been up for a lot of hours.
Losing your touch.
I'm not used to working long hours anymore. 26 hours, 30 some hours was no shot in the dark, and now I'm getting old and fat, and I can't do it anymore.
Yeah. So another thing, and Brett was going over a Megger, and so a Megger is just not a magic short finder, just so you guys know. I've seen guys do that where they just break the Megger out on every little thing. And not every Megger is the same. So that Subco Megger is not a Megger. That thing's a giant pile of crap. I mean, if it's got Christmas tree lights on it and it says good or bad, that is not a Megger. I mean, I'm sorry. Like, you can go on Amazon for the same price as that and get a legitimate Chinese maker. And I mean, like 3 or 4 guys I found them for when a couple years ago, and they were like $50, and they were every bit as good as my Fluke. We were doing testing with it. It was like within 0.2 or 3 of a mega ohm of what my Fluke read every single time. So I use a Fluke 1587. I mean, it's a pretty standard mega.
I think I have the 1520 because I did. I think the first one I ever bought was, and I had it for about 12 or 15 years, and it, I just hadn't used it for a while, and I let the batteries go, and my fault. But it ate it up, and then the old Mega that I had was like the size of a fucking cinder block. It took 4D batteries to induce 1,000 volts, and this thing was just wicked insane. And we actually, when that I got tool replacement on the next one, and this one only took like a couple, like 9 volts or something like that, or whatever. It was like a quarter of the size of my old Mega, but basically did the same damn thing. And man, I stand behind that Fluke. Yeah.
Yeah, Fluke is definitely better. I mean, some of those cheaper ones aren't bad, but that Supco thing it's a toy. I mean, if it tells you things in good or bad, and then some random numbers in between, it's not meant for that. A Mega is meant to be a predictive tool, like it's supposed to meg motors and compressors over time, so you can predict, when a motor's going to fail. So you're supposed to, meg them, on PMs and stuff. I mean, I don't do that. I mean, if it's a big motor, I mean, we would do it, but you meg ohm stuff out on PMs and you make a note. And as the meg ohms start decreasing, I mean, it's a predictive thing when you have to do maintenance or tear a motor apart. I mean, when a winding is going to fail. I mean, low meg ohms could be anything from liquid refrigerant in the crankcase. They could be from contaminated oil, acid in the oil. I mean, so there's a lot of things that could cause, meg ohm issues. Also, never, ever mega scroll in a vacuum.
Have you done it?
No, but I know it'll blow the windings out.
Yes, it will. So since we're talking about that, so do you because I really don't know what causes the windings just to blow the hell out of a compressor?
You mean the fusel light to blow?
The what?
Like the fusel light to blow out of the windings?
Where it just blows out, where you have refrigerant just blowing out the damn side of the thing.
It's just a failure. Like it could be a short, it could be high amps, it could be high current. I mean, I've seen it where it shorts on a leg in a compressor, and then it blows the fusel light out, and then you're cleaning for hours.
Yeah.
So that's one thing to look at. That's why a Mega is more of a predictive tool, but like it is nice for finding, small shorts to ground. Sometimes your meter won't pick up, or some components that are going to fail, or like it picks up carbon tracking a lot better. So, I mean, I have a Mega. I don't use it every day. I mean, there is times I use it though. I mean, I meg new pieces of equipment when I start them up. I generally will mark the meg ohms with it that it was when it was.
I'm calling bullshit. I'm calling bullshit right now.
Well, if I start a new rack, I do. If I'm not doing it for a single unit. Do you know how many times I want to start a rack and there's the direct short somewhere? Or a manufacturer didn't put bolts in, or there's compressor bolts that are touching each other. I remember I did a Carnot startup one time for a CO2 rack, and there was 7 compressors with 100 amp fuses in them, and L2 and L3 lugs were touching in every one of them. So the guy goes to turn them on. It was like, boom, 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 boom. And it's like, okay, let's turn one at a time, not 4. And yeah, that was loud.
All right. Well, I can see if you get gun shy after that. I could understand that. But like, normally, come on, a startup. It's
I'd make the compressors.
Do you really?
Yeah.
Then you had
I have blown myself up. I can't even count how many times now. So I'm running out of lives here.
Is that why you're missing like eyebrow right there?
You're a dick. So no, I'm pretty cautious about that. If you also want a good time, you just tell the apprentice to hold the mega leads in his hand and put it on 1,000, hit the button.
I'll give you $50 if you do it.
I'd do it.
First person that takes a megger and posts a video of them doing, they'll give it up to them for 1,000 volts. I'll send them a whole bunch of swirling shit.
Jesus. But, yeah, guys, that's a good overview on like how to find shorts on a rack, and same with cases. I mean, cases are the same way. Like, just start looking in rails. I mean, if it's the anti-sweats, start looking around the doors, looking for burn marks. If it's heaters, if you blew all heaters, I mean, I'm very reluctant just to throw fuses in heaters. I go pull the pans out first and make sure that the ends of the heaters aren't blown off.
Yeah, that could happen.
So I've had that happen and put the fuse back in, and all of a sudden it blows a hole in the side of the coil. Then you're just even more mad because the case is iced up now, and there's a hole in the coil.
You found the leak though, right?
Found a leak, made a leak, and found a short.
That's amazing. Well, guys, I think that's going to cover it. I want to thank you guys. I think this week we're going to hit 20,000 downloads, as we've been doing this podcast now for about 6 months. I know it's summertime. I know you guys are busting your asses out there, and I appreciate you guys listening. I really do. Man, I couldn't be more excited. Come September, we're going to have an announcement. Man, I'm just extremely humbled, man. And I've met so many guys, in the field that have just, shown appreciation for what we're trying to do, and just basically just put out some information. And I appreciate it. That's all I wanted to say.
Same here, guys. I appreciate you guys all listening and, helping us grow it as much as we can, and see what it grows into. All right, guys, have a nice night and a nice weekend. Stay safe out there.
All right, bye.